approaches 0. Integral from b to 1. What is the antiderivative of x to the 1/3? 1 over x, which is negative 1/3. What?
X to the 2/3 and then 3/2.
Very good. From b to 1. Plug in 1 and I get 3 over 2. Oh, and I need to go back and talk a little bit about that. Minus plugging in b, I get 3/2 b to the 2/3. Technically, on this limit, I don't have to approach 0 from both sides. Now, this one it wouldn't matter, but I only have to approach 0 from the right. Does everyone know what I mean by that? So, mental note. Why do I only have to approach 0 from the right? Okay, it's only going from 0 to 1, so I'm only looking at the right inside of that. Then again, this particular problem, it wouldn't matter, but for future problems, as you know, sometimes limits exist only from the right and not from both sides. We are only concerned from the right. As b approaches 0 from any side, 3/2. Remember, this was the other bell ringer problem. Remember that other bell ringer problem that we did? And your calculator told you the answer was 3/2. And I said, well, at some point in the notes, figure out how they got that. The first thing. Okay, so let's do the second one.
Is it 3/2 because b is a 0? And then
so if you plug in a 0, it's just the 3/2 is 0.
3/2 minus 0.
Oh, okay.
Okay, let's look at the next one. The next one is a little bit more complicated than its integration. It's anti-differentiation. So we will have some complicated integration come up every now and again. First thing I'm going to do is rewrite them. Step 1, rewrite it as a proper interval. A limit as b approaches infinity. Integral from 1 to b. And is there anything you would do to that before you started the problem? I would distribute it first. You could try to use substitution, but as it sits, nothing seems to work. So the first thing I would do is distribute. I can break that into 2 integrals. The first one is e to the negative x, which is a very easy integral to do. What is the second integral, and how are you going to go about it? Very good. Integration by parts. X times e to the negative x. X will quickly go away. E to the negative x will be our dv. So it's a very good integration by parts. So this is the first time you kind of had to make that choice. You know, what am I going to do here? What kind of integration technique am I going to use? You will have some on your homework where you have to make those decisions. Partial fractions, parts, is it just a u substitution? What can I use to find this antiderivative? The first piece, I'm just going to go ahead and find the antiderivative, because we can. What's the antiderivative of e to the negative x? Negative e to the negative x. Technically, that's a u substitution problem, but you could probably do it in your head. It's up to you, though, if you need to do u substitution. Minus the integral of x e to the x, negative x dx from 1 to b. The limit does go back. So you might side note here, or you could just work it in the problem, but I do need to do integration by parts on that second integral. So I'm going to let u equal x, dv equal e to the x, e to the negative x, sorry. du would equal dx. B would equal negative e to the negative x, even though I'm anti-differentiating, it turns out the second one. So I get careful with that negative sign. U times v, which is negative x e to the negative x, minus the integral of v du. Okay, if I change that to a plus, a negative is positive. And this is going from 1 to b, and this is from 1 to b. Okay, so now I'm going to find the antiderivative of that, and I get negative x e to the negative x. What is the antiderivative of e to the negative x? Negative e to the negative x. From let's b, and I'm also getting negative e to the negative x from 1 to b over here. And you could have distributed that negative through while you were working. Just don't forget that I guess it does go to the pieces. Questions so far? We haven't what? I believe so. Yes, questions here? The antiderivative. Yes, it does simplify. Are you using your calculator? Yes, of course. There's a lot of simplification. In fact, you're going to notice things are going to cancel as we work. So I have the limit as b approaches infinity. I'm going to go ahead and combine this all together, and then it'll all be from 1 to b. Negative e to the negative x plus x e to the negative x plus e to the negative x. Does everyone agree? And so the simplification Joseph is probably talking about is that the negative e to the negative x and the positive e to the negative x cancel, and I'm just left with x e to the negative x. Plug in b and plug in 1. I get b e to the negative b plus 1 e to the negative 1. Any questions so far? Questions so far? Yes. Where? Here. Oh, you're right. Plug in b. Plug in a. Thank you. Any questions about that so far? It's a little tricky, doesn't it?
Infinity over e to the infinity. So would that be 0 or would that be 1? Because it's infinity over infinity because.
Well, we have to ask ourselves the question. It's kind of like, remember b is like an x, right? So this is really like b over e to the b. Does everyone agree? And when you have a fraction like that, you have a couple of options. You could use L'Hopital's rule, which we will revisit that tomorrow, remind ourselves some L'Hopital stuff. We could use L'Hopital's rule there, or we could think about which one grows faster, right? And which one definitely grows faster. The e to the b grows faster, which does pull that thing down to 0. So the answer to this is negative e to the negative 1. So that one was the tough one, mainly because the antiderivative was tough, but it did also have a somewhat difficult limit involved as well.
You can have infinities that are more equal to infinity than infinity.
Yes, there are levels of infinity, yes.
Infinite conversion.
Alright, let's do this next one. Before I do this next one, I want you to break brainstorm as we're working this one. Now we're going to work this first one completely. But brainstorm which ones would converge and which ones would diverge. Didn't we just work a problem almost identical to that problem on the left? Except it was x to the 1/3. And it converged. We got 3 halves, right? So my question is, does this one also converge or not? And maybe why or why not? So let's find out. Converge means you get an answer, a number. Diverge means the answer is infinity or negative infinity, so there is no answer. So the area is not capable of being found. We'll talk much more about convergence and divergence when we use this kind of linked into that a little bit, but we're not doing that for a while. It's the last chapter. Right before the AP exam. Okay. First of all, what's the rewrite? Where do I need a limit at? 0. What is the antiderivative of x to the 3rd? Okay. It's negative 3 power, so we're adding 1 to the exponent, which gives us a negative 2. And negative 1/2, because we divide by 3 power. Okay. And again, I am approaching 0 from the right. It's good to know where I'm approaching 0 from. It just converge, maybe it will converge from the side I care about. I'm going to rewrite this as 1 over negative 2x squared. You could have done that all in one step. Plug in 1, I get negative 1/2. Minus, plug in a, minus the negative, I get plus 1 over 2a squared. Look at, the limit is a approaches 0 from the right. Well, negative 1/2, the limit of that's just negative 1/2, so my big question is, what's the limit of that thing as a approaches 0 from the right? 1 over 0, what's that mean?
It's going to be infinity.
Good, it's a vertical asymptote, right? When I get 0 on the bottom and not on the top, it's a vertical asymptote. That limit is going to infinity. So what does that mean if part of the limit is going to infinity? Oh, so this diverges. Now, I want to ask you a question. Why did this one diverge, but x to the 1/3 on bottom converge? True. When I added 1 to 1/3, what did the power become, or negative 1/3? What did the power become? It became positive. So I no longer had an asymptote at all in the antiderivative. So wouldn't you agree, if this is the setup, if the exponent is between 0 and 1, not including 1, it's going to converge? Because when I do the antiderivative, I'll add 1 to it and get a positive exponent, and we'll be able to find a limit. But if it's like this and the power is greater than 1 or equal to 1, because we actually did 1 over x earlier in the lesson. So there's a theorem in your textbook that I didn't write down, but it says if you have this setup, the integral from 0, and it could be to anything, it wouldn't have to be to 1, but from 0 to anything of 1 over x to the p power. If p is between 0 and 1, not including 1, then the integral converges. If p is greater than or equal to 1, then the integral diverges. So it's kind of nice to note that to kind of have an idea of how that would work. So in your textbook, you'll see that theorem. You can kind of see why. It doesn't necessarily mean you have to memorize it, but it's good to know why that works because of that antiderivative property. It means you can shortcut your work on multiple choice. That's right. If one of these comes up on multiple choice, you could not do any work if it's a divergent integral answer. So if it's between 0 and 1, not including 1 over this power.
Oh, 1 over.
Does it have both answers?
Sometimes we'll say divergence, sometimes we'll say...
I would say if it says non-existent, then that would be divergent. It surely didn't want to put both of those down. Okay, let's look at the next one. Where is my problem? At 27. It's not at 0, right? It's at 27. Why is it at 27? Cube is 0, 0. It's on the bottom. That's a problem. So we've got to mark black and check that 0. Or sorry, yeah, 27. So I'm going to do the limit as b approaches 27. And which side am I approaching 27 from? From the left this time. Again, it's not a huge deal unless it only has the limit from one side, and so it is important for you to know which side you are looking for the limit. The integral from 0 to b, and I am going to go ahead and write this as 27 minus x to the negative 1/3 power to help my brain out. I recommend a u substitution here. I don't require a u substitution, but I recommend one. Why do I recommend a u substitution? But I have 27 minus x as my thing under the cube root. That's a lot to think about in your head. What's going to happen with that 27 minus x? So I recommend a u substitution. I can do it without a u substitution, but based on my experience grading your papers, I would use a u substitution. But some of you can get away with it. Some of you, after that discussion, already know the answer because you thought about it. So the antiderivative. Now, if I do a u substitution, if I happen to rewrite the integral, I want you to know if you ever rewrite the integral, with the u's involved, like that, if you write 0 to b there, AP will count a point off on that, on open response. Why will they count a point off if you put 0 to b right there? Right. If we're going to change the u's, we change limits too. Now, I do not have a problem with you leaving this blank for a moment, finding the integral, substituting u back in, and then going back to 0 to b. But leave them blank if you're going to do that. If you're going to put limits here, it needs to be 27 to 27 minus b. I don't know how I got that. So if you want to put limits there, do it. Just do it correctly. And it doesn't make any difference to me which way you work it. Just be careful. Don't write 0 to b right here. AP will dock you for that. So I'll go ahead. 27 minus b. Just let you see how that's worked. The antiderivative of u to the negative 1/3 is 3/2 u to the 2/3. If you want to leave it, you can. And you'll notice if you leave it, you would get the exact same thing that you would if you plugged it back in and plugged it b. It doesn't make any difference. minus b to the 2/3 power minus 3 over 2 27 to the 2/3 power. 27 to the 2/3 power is something I can do. The cube root of 27, what's the cube root of 27? And 3 squared. So 9 times 3 over 2 is 27 over 2. That's what I'm going to have to think about. So I'm approaching 27 from the left. This is a cube root squared. What's a number to the left of 27 but really, really, really close to it? 26.99999. Right, something really, really close. Oh, good question. What, negative 1? Did I lose a negative? That negative? Yeah. Right. Sorry, thank you. That's negative. Negative, positive, positive. Good call. So I want to plug in 26.9999999. Wouldn't you agree that's going to be a teeny tiny number? Like really close to 0. Closer I get to 27, closer that is to 0. 0 to the 2/3 power. 0. There's actually not even a problem there, is there? Because the power became positive. Remember, it was a negative 1/3 power. But when I added 1 to it, so this is another one of those cases. The reason it's convergent is because of that power that became positive. So that approaches 0. Yeah, but maybe, I mean, that it goes to another number, it's possible. 0 is a common element. One more. How many of you know the answer before I start? It's probably divergence. You see how it's kind of nice to know that? We'll work it just for fun. So, first of all, what's the rewrite? And on the AP exam on open response, make sure you show that rewrite on multiple choice. I don't care how you do it. But on open response, make sure you show the rewrite so that the reader doesn't dock you points for writing a profit interval. So, what's the rewrite?
The approach is 1 of the integral of e to the 3 is the same.
You may not feel the need for a u substitution on this one since the derivative of x minus 1 is just 1. Does everyone know what I mean by that? Where the derivative of 27 minus x was a negative 1, so we decided we wanted a u substitution there. Something to think about when you're deciding whether you need to do a u substitution or not. So what's the derivative of that inside the value? So I have x minus 1 to the 3/2 power, the negative 3/2 power really. If I add 1 to that power, by the way, which way am I approaching 1 from? If I add 1 to that power, I get x to the 1/2. X minus 1 to the 1/2 times 2. Does everyone agree? Sorry. Negative 1/2 times negative 2. Thank you. Definitely would be negative 1/2. And I add 1 to negative 3 over 2. I get negative 1/2. Any questions about that? From b to 3. I can plug in 3. And if I do plug in 3, 3 minus 1 is 2. So I get negative 2 over the square root of 3. Or sorry, square root of 2. Minus negative 2 is plus 2. B minus 1 is negative 1. Any questions about that so far? Now I want to talk about why it's important, the left-right thing. Now this one is going to be divergent because the 1/2 is negative, so we have a power on the bottom. But what if the power had been positive 1/2? What do you know that you cannot plug into a positive 1/2 power? You can't plug in a negative number, so you couldn't plug anything in from the left of 1. But the good thing is you're not even trying to plug anything to the left of 1. You're trying to plug in something to the right of 1. So that's why it's important. Does everyone know what I mean by that? That's why it's important that you know whether you're going from the left or the right. On this one, because we have b minus 1 in the square root on the denominator, we have a vertical asymptote at 1. So as we approach 1 from the right, it's either infinity or negative infinity. I don't really care which one it is. Either way, the answer is the same. It is divergence. Any questions about that one? But a 1/2 power, a positive 1/2 power is why you would need to know from the left or from the right. Homework